All right, so chapter 3, this is like one of my favorite chapters. I just think it's fun. And if you're, if you don't really like math, I mean, this is, you could say, it's not really like, there's no numbers. There's lots of words, so you should be happy about that. All right, so basically what chapter 3 is about is logic. All right, so the first thing we're going to do is understand what is a statement. So a statement is a sentence that can either be true or false. Okay, so first we're just answering the question, is this a statement? So, I like pizza. Yes, that is a statement. So we're not stating whether it's true or not, we're just telling whether it's a statement or not. Okay, so pizza is a vegetable. That is a statement. Order me a pizza. That is not a statement. That is a command. So it wouldn't make sense to say whether this is true or false because it's not a statement. And then number 4, what kind of pizza do you like? That is a question. That is not a statement. It is neither true nor false. It's a question. Okay. All right, so every statement has a negation. So the negation of a statement is another statement with the opposite meaning. So if P is a statement, then not P, which is represented like with a tilde P means not P. That's the negation of P. So if P is true, not P is false, and vice versa, because they're opposites. Okay. So we want to write the negation of the following statements. So the statement is, I like pizza. The negation would be, I do not like pizza. Or you could say, I don't like pizza. Either way. Okay, number 6 says today is March 3rd, 2010. So the negation of that statement would be today is not March 3rd, 2010. All right, so number 7 says dogs do not like cats. So the negation of that statement would be dogs like cats. Okay. Any questions so far? This is so much fun, Mary. It's my favorite. Okay.
Is there a test?
Yes. You want your test?
I don't like it.
We can, if you have questions about your test, we'll do that at the end of class.
I'm not going to my last one apart.
Okay, so then we'll look at what we call quantified statements. So these are just a little bit more difficult because you have to know, you have to think about it a little bit more. So these are statements using words like all, none, or some. All right, so if the statement is everyone likes pizza, the negation of that would be some people do not like pizza, or at least one person does not like pizza. Okay. So the negation of everyone is not no one. Okay, because and one way you can know that that's the case is that if you had the statement no one likes pizza, because this is the common mistake that people will make. They would say that the negation would be no one likes pizza. However, the reality is that both of these statements are false, right? Okay, well, if both of these statements are false, then they cannot be negations of one another, because two statements that are negations of one another, one of them has to be true and the other one has to be false. So, everyone likes pizza, that is false. I'm sure there's at least one person we could find that does not. So, this would be false, this would be true. Okay? Okay. So then number 10, the statement is some people like pizza. All right, well, the negation of that would be no one likes pizza. Okay, so again, this is true, this is false. So
This will be like, everyone likes pizza though.
everyone likes pizza really is also a false statement, right?
Yeah,
So that would not work. Oh, okay, I see what you're saying for this. So, no, that still, would not, that would not work, because actually if you use the statement, everyone likes pizza, the thing is, it is possible for both of these two statements to both be true. So that wouldn't work either. Okay, so it could be, I mean, in reality, okay, we probably know that it's not, but it's possible that if you have the statement, everyone likes pizza, that could be true, and then at the same time, the statement, some people like pizza, would also be true.
So if we have the statement that's true, we have to get another one that's false, right?
Yes. Yes, and so, I mean, obviously, you know, just because one statement's true and the other one's false doesn't necessarily mean they're negations, but that does have to be the case in order for them to be negations of each other. They kind of have to be like mutually exclusive, like they could not ever be both true at the same time, you know. Okay. So for number 11, it says no pizzas have cheese. And so your negation of that could be some pizzas have cheese, or at least one pizza has cheese. Okay. So number 12, what statement is represented by this diagram? Any ideas? A statement similar to some of the statements that we were just talking about. Yeah. So that diagram is trying to show you that all food is pizza. This is not probably a good topic to be talking about because I'm really hungry, which I probably was when I wrote this lesson too. Okay, so the statement that it's showing in that diagram is that all food is pizza. Okay, so is that true or false? Well, that is false, obviously. So what is the negation of that statement? Some food is not pizza. Okay. All right. I'm going to give you the Chapter 3 worksheet handout. Take one of those and pass that stack around. You should be able to do number 1 through 6 at this point. So go ahead and do that.
I think there's just 1 minute.
And then you can check the answers. I think all the answers are all together at the last few pages. Yeah.
are some that at least one of the same.
Pretty much, yeah. Some and at least one are basically the same thing. Any other questions before moving on?
So if it says some people do, you can always say that no one does. Like
Mhm.
you can,
Mm-hmm.
if it says nothing does, you can say
Some do.
some do.
Mm-hmm.
Always, it's not gonna be.
Mm-hmm.
Okay.
Mm-hmm. Okay. Section 3.2. All right, so we're going to, in this section, write statements in symbolic form. All right, so here are some of the symbols that we're going to be using. So you have the or symbol, looks like a V. The and symbol is just like flipped upside down, so it kind of looks like a capital A, but without a bar across it. Then we have the arrow, which is an implication. So P arrow Q is like P, if P, then Q. Or it could sometimes say P implies Q. And then if you have a double arrow, that's if and only if. So P, if and only if Q. And it can also sometimes be written as like P is necessary and sufficient for. So that's basically like, you have the arrow and then you have the double arrow. So it's also, if you could think of it as P implies Q and also Q implies P or something like that. Okay, so here's an example. So we're going to be working with 3 statements. So P represents the statement, I go to school. Q represents the statement, I do my homework. And R represents the statement, I eat pizza. So number 1 is basically saying P and Q. So to write that in words, that would be, I go to school. And I do my homework. And then number 2 is saying P or R. So that would be, I go to school or I eat pizza. And then number 3 is if P, then Q. So if I go to school, then I do my homework. And then number 4 is R, if and only if Q. So I eat pizza if and only if I do my homework. Okay. Any questions so far? Okay. So number 5, P and Q implies R, or if P and Q, then R. So if I go to school and I do my homework, then I eat pizza. I don't know. I never understand that because people walk around with the speakerphone on. It's so weird. I think so. Yeah, that's what it sounded like. Okay. Okay, yeah, that's me all the time. Sorry. At least that way you only have to hear one side of the conversation. I know. I try not to be a douche about it. I don't know, but still, it happens. All right. Number 6. Okay, so the tilde, that's the negation. So not P or Q. So that's I don't go to school or I do my homework. Okay. And then number 7, I eat pizza if and only if I don't go to school. Okay. All right, so let's see. This one, we have not Q or R. If not Q or R, then P. So if I don't do my homework or eat pizza, then I go to school. Okay, so let's maybe take a worksheet break right there. Go ahead and, let's see, that would be number 7 through 12. We could work on those. Mean like on the answer? Let me look. Let's look. You're right. Yeah.
Any questions?
All right, let's continue with the notes. All right, so just translating it in the other direction is what we're doing now. So number 9 says, if I do not do my homework, then I do not eat pizza. Okay, so that's not, if not P, then not R. So not P. Oh, whoops. Okay. Q. If I don't do my homework, then I do not eat pizza.
It's like when I go out in the hieroglyphics or something.
It's not that bad.
Could you like, is it possible to do it in parentheses and then have it on the outside?
No, that it doesn't quite work that way. There.
It's only the parentheses if it has like another component, right?
Yeah. Yeah. So let's see. Like if in order to do it that way, it would have to be like, it is false that Q implies R. You know, it would have to be kind of like a weird statement like that. In that case, then yeah, you would have the tilde on the outside of the parentheses. Q implies R. So, but yeah. All right. And then number 10, doing my homework and eating pizza is necessary and sufficient for me to go to school. Okay, so doing the homework, that's Q, and eating pizza, that's R, and that's going to be in parentheses, is necessary and sufficient for, so that's the double arrow for me to go to school, which is P.
Does it go in parentheses because that's first?
Not necessarily. I mean, pretty much any time if you have more than 2 statements, you're going to have parentheses around something. But what the statement is saying is that both of these things, this and this, are necessary and sufficient for this. So. Okay, and number 11, if I do not go to school, so that's tilde P, and I do not do my homework, so that's tilde R. All right, so that would be in the parentheses. So both of those things. Then I do not eat pizza. Oh, whoops, I messed up my letters here. Sorry. But yeah, that's supposed to be tilde P and tilde Q. And then implies tilde R. Okay, any questions about that? Okay. And then number 12, if I go to school, I will eat pizza and not do my homework. All right, so if I go to school, so P implies two things. So I'm going to put parentheses around those two things. I will eat pizza, which is R, and not do the homework. So that's tilde Q. All right, so they left out the word then, but I mean, I think it still retains the same meaning as if they had put the word then in there, so. All right, any questions about that? So then you could finish up number 13 through 17.
questions before we move on?
All right, so section 3.3 is about truth tables. All right, so I'll start off with the truth tables for each of the symbols. So the easiest one is the negation. So if P is true, then not P is false. If P is false, then not P is true. Okay. And then let's look at the conjunction, which is the and statement. Okay, so basically every time we have a truth table with two basic statements, P and Q, we're filling out the P and the Q columns to include every possible combination of true and false for P and Q. And we'll do it this way, where P is TTFF and then Q is TFTF. And typically that'll be like on a test or something, that'll already be given for you, so you don't really need to worry about it, but yeah. Okay, so those are all the possible combinations of P and Q. So then P and Q, so the statement P and Q is only true when both P and Q are both true. So it's true there, and then all the rest of these will be false. So the and, it's only true if they're both true. And then for the false, so first two columns are the same. Those are just all the possibilities for P and Q. And then the or statement is only false if they're both false. And then the rest of the time it's true. So basically it's just, when you have the or statement, it's just at least one of those two has to be true. So as long as at least one of them is true, then it's true. The only time it's false is if they're both false. Then we have the implication, which is the arrow. Okay, so this one is a little bit trickier. So if P, then Q. So we want to determine if that statement is true. So the only time this statement is false is if P is true and Q is false. And then all of the rest of the time, it's true. Okay, so let me give you an example to help you understand why that is true. Okay, so let's say you have let's see. Let's see, we can just use the same example that we used in the last section. All right. All right, so let's do that. All right, so statement P says I go to school. Statement Q says I do my homework. All right, so then let's look at the statement for if P, then Q. All right, so if I go to school and I do my homework, then the statement, if P then Q, is true. So let's write that out too. So the P implies Q statement would be, if I go to school, then I will do my homework. All right, so that's the P implies Q statement. All right, so if I do go to school and I do my homework, then this statement was true, right? Okay, what if I go to school but do not do my homework? Then this statement is false. You could say that I lied in this statement. If I went to school but did not do my homework, right? Okay. Now, what if I don't go to school at all? Then there's no way that this statement could be a lie. So if I don't go to school, then I don't need to do my homework, according to this, for this statement to be true. So if the first part of it is false, it doesn't matter what happens with the second part of it. It's still a true statement. It's kind of silly. This is what they would call vacuously true. Like, it's true just because the premise of it is false, basically. So, but you still could not accuse a statement of being a lie as long as the person did not go to school. So, it's kind of like saying, you know, if I said, well, I don't know, something like, you know, if pigs fly, then, or whatever, then I can say whatever I want because I've started it out with a false premise, you know? And it doesn't really matter. So that's just one of the many ways that, you know, like lawyers and politicians try to like lie to you and stuff like that, or, you know, but you can't, if they based it on a false premise, then technically their statement wasn't a lie, kind of thing. So when you're looking at somebody's argument, you want to see if, you know, what are they basing on it, what assumptions are they making at the beginning, because if those are false, then, you know, the whole thing is kind of pointless. You know, it's not that it's a false or invalid argument, it's just based on a false premise. Okay. All right, and then the last one that we'll look at is the biconditional, which is the double arrow. And so with this one, basically, in order for that double arrow statement to be true, both P and Q should have the same truth value. So that means if they're both true, then it's true. If they're both false, it's also true. So it's kind of like saying they're equal. They have an equal truth value. So if they're both true, it's true. If they're both false, it's true. And then otherwise, it's false. Okay, because, you know, the double arrow is basically just like P implies Q, and also Q implies P. So it's kind of like P implies Q has to be true, and then also Q implies P also has to be true. So that works if they're both true or both false. But if one of them is true, one of them is false, then it's false. Okay. All right, so those, basically we're using that information to fill out all of our truth tables. So number 1, all right, so P's and Q's that's just your standard P's and Q's there. True, true, false, false, true, false, true, false. Sure. Mind your P's and Q's. Okay, so the next column we have is tilde P or not P. So that's literally just the opposite of P. So in this case, that would be F, F, T, T. All right, and then Q and not P. All right, so in that case, focus on the Q and the not P columns. And in order for that last column to be true, then they both have to be true. So that's right there. And then the rest of them are false. Okay. Any questions? Okay. Number 2, we have 3 basic statements. We have P, Q, as well as R. So, so in this case, all right, so then in this case, since we have that, we're going to do, for P, we're going to do 4 T's and 4 F's. And then for Q, we'll do TTFF, TTFF. And then for R, do every other one, TF, 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 TF. You mean that many rows? I'm sorry. Yeah. I'm sorry. Thank you for telling me, but I guess there's nothing I can do about it at this point. Sorry about that. Okay. I can try to fix that for the future. Doesn't do y'all any good, but. All right. All right, so then not Q, so that'll just be the opposite of Q. So in this case, what'll be FFTT, FFTT. And then next we have not Q or P, okay? So we're focusing on the not Q column and the P column for this next one. And then, so with the or statement, the only time that it is false is if they are both false. And then as long as just one of them is true, it's going to be true. So that's going to be 4 T's here because I know P is true on the first 4 lines. And then I'll have a couple of F's because they're both false. And then a couple more T's because not Q is true on that. Okay. And then on the last column, we have R implies not Q or P. So for that one, we will focus on the R column and then the not Q or P column. And so the only time when this last column is going to be false is if the first statement, the R, is true, and at the same time the second statement is false. So I think that only occurs one time right there. The rest of them should all be true. Pretty much, yeah, you need to know that. Yes.
Yay.
So, but I mean, you know, just think about how, you know, it kind of makes sense logically. So if I tell you I did this and I also did that, well, in order for that to be true, I would have to do both of those things, right? So they would both have to be true. If I just said, I'm going to do this or that, then I only have to do one of those two things. So only one of them has to be true.
So there's only one of them that's true, which one is true or false? Like,
Well, if for like the or statement, as long as one of them, yeah, as long as one of them is true, then it's true. So it's either or. So, like, you know, that's why, let's see, so the or statement, we were looking at these two, so, and I knew that all of these are T's, so that automatically means this or statement is all truths right here, because it just has to be one of them is true. So if one of them is true, then you would have to put a T here. And then the false, 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 true. So if one of them is true, that's true. And then one of them is true, so that's true. So it's either one. So as long as just one of them is true, then the or statement is true. It is fun. Once you get the hang of it, it's really fun. Okay. So number 3, okay, I just have the P and the Q for this one. So I'll just do, for P, I'll do T, T, F, F. And then for Q, I'll do T, F, T, F. Okay. And then, let's see. Y'all don't really need to worry too much about having to fill this part in right here, because I think pretty much always, at least on my tests and quizzes, like that will be given. But I don't know if you might see some on the homework. I guess yeah, and I guess there are some occasions when you might kind of need to be able to figure it out. But basically, you just want to write down which individual statements should I write down up here in order to get to this statement at the end. So basically, I'm going to do a column for not Q, I'm going to do a column for not P, and then I'm going to do one column for this whole thing right here of not Q or not P. So that's what I want to do for right here. All right, so, and like, I guess it doesn't matter if you do, I'm going to do not Q first, and then not P. and then the not Q or not, and not P. Okay. So then not Q, so that's just the opposite of Q. So then that's, in this case, it'll be FT, FT. And then for not P, that's the opposite of P. So that'll be FFTT. Okay, and then not Q and not P. So in order for that to be true, both of the not Q and the not P, they both have to be true in order for this to be true. So that's only true down there at the bottom in this case, and the rest of those are false because at least one of those is false. Okay. And then the last column is the double arrow, and it's P if and only if this other thing. So in order for the double arrow statement to be true, those two columns should have the same letter in them, either both true or both false. If they have a different letter, it's false. So that'll be false, false, true, false. So for the double arrow, these should be the same in order for it to be true. Those are different, so that's false. Those are different, so that's false. These are the same, so that's true. These are different, so that's false. All right, and then number 4, determine the truth value using truth tables. Okay, so I'm gonna say, let's see. Okay, let's say that this statement, Obama is the president, let's say that's statement P. And then for 1 + 1 = 2, let's say that's statement Q. And then I'm going to say that statement R would represent 3 + 2 = 6, because I don't know, I just don't want to make it a statement. I don't want to make it be like a negative statement of not equal to. I'd rather have R represent the statement 3 + 2 = 6, which means that would be not R. 3 + 2 is not equal to 6 would represent not R. All right, so P. Okay, so that statement is false. So we actually don't need all of these rows. We really only need, since we actually know what the statement is and we can determine whether it's true or false, we only really need the one row, and we're just going to write whether that actual statement is true or false. So that's false. And then statement Q is true. 1 + 1 = 2, that's true. And then statement R, 3 + 2 = 6, is false. All right, and then I also need to determine how to write out the entire statement using symbols. Okay, so that would be P if and only if Q and, whoops, not and, that's or not R. And I would put parentheses around the Q or not R portion. So that represents the whole entire statement. So my goal is to determine if this statement right here is true or false. So I'm going to do a column for not R, And then I'm gonna do a column for Q or not R. And that should be all only other columns I need to do. So, not R. So the opposite of R, since R is false, the opposite of R is true. And then I'll have another column for Q or not R. So Q or not R is true. Okay, and then the last one there at the end, we have P is false, and then Q or not R is true. And since those are different, this statement is false. So basically the final answer they're looking for here is false. Okay. So go ahead then on the worksheet. I would say on here, if you look on here, I've kind of wrote out all that stuff for you. If you want to maybe, yeah. So if you want to write out, that way you don't have to worry about figuring out what all this is supposed to be. I have it written down right here for you. And also here. So yeah, you work on those. And I'll go ahead and give you the review for the next test. Did you have a question?
No.